Hey guys, Miss Tarpon here. Another lecture for Earth Science. I think this will be your very last one this semester. So congratulations, almost done. Hang in there. This quick little video is just going to review some of the environmental issues that we face today. And this is going to go along with your big standard 3 over human impacts and the Earth. So quick little question, which of the following should we be concerned about? Here on the side, and all of the above, of course. Acid rain, air pollution, animal extinctions, all of the above are issues that we face today. So human activities a lot of times do interrupt the natural balance of things in the environment. As you guys have already seen in a couple different units this semester, we've looked at climate change, we've looked at utilization of resources like rocks and minerals. And so a lot of times what that creates is something called pollution. When we have pollution, that requires some type of either cleaning up or regulation. And of course, money is always a question when it comes to anything. Money, government, opinions, all those fun topics. All right, so human activities, like we said, can create pollutants. So we make pollutants when we make products. So like anytime we're making oil or not making oil, but mining for oil or making plastics from oil, for example, when we're consuming products, if we're making electricity, well, that's generating electricity. But if we're consuming really anything that is not natural, a lot of times that can create some type of pollution. We're going to go through some specific examples. So pollutants most of the time are either in the air, in the water, in the soil, or maybe a combination of those three. Of course, litter is one type of pollution that's very easy visually to see, not pleasing to the eye, but something that we do see. Put that away. And then pollution of rivers and lakes, that can lead to other problems. We're going to get into that. And then, of course, pesticides when we're growing food. Some of these pesticides are considered pollutants. So types of pollutants, there's two main classifications. One is primary, the other is secondary. So for primary pollutants, these are those that enter directly from a source. So for example, pollutants that come directly out of a smokestack at a power plant or at a factory, directly from the exhaust of a car. And we're going to get into some specific names, but this is just for the general sake of being general. A point source, a tall smokestack, like we said with the power plant or factory, an area source, a swamp or a community. And so this would be like pollution going into the water and then infiltrating a larger area or a larger community. Secondary pollutants are different from primary pollutants because they're formed when primary pollutants combine with water vapor and also other things in the atmosphere, like sunlight is another example. So sulfuric acid, carbonic acid, nitrous acid, and nitric acid. We'll go through again some more specific examples, kind of more layman's terms rather than the chemical. The toxicology, anytime you see ology, remember that's the study of, like geology is the study of rocks. So toxicology is the study of how toxins and pollutants interact with and cause damage to living things. So when we're talking about the environment, there's environmental toxicology, how toxic substances interact with an ecosystem. And there's human toxicology, how toxic substances affect and are handled by the human body. So as you can imagine, these two sometimes go hand in hand because as humans, although we may not think of it that way, we're still part of the natural ecosystem. It's just a couple terms for you to know. Okay, so one really kind of famous and good example of a secondary pollutant is smog. You may have heard of that term before. Smog is a secondary pollutant. It is a type of air pollution. So some of the primary pollutants that go into that making of the secondary pollutant, which is smog, are the emissions from power plants, from vehicles, steel mills, chemical plants. So carbon monoxide, carbon dioxide, nitrogen oxides, all these are going to combine with ozone that's already in the atmosphere. They're going to combine with water vapor. Sunlight is a big part of it too, all to make this one kind of bigger umbrella that we call smog. So you may have seen like pictures of smog over big cities. You may have heard of the Great Smog in London. That was a long time ago that unfortunately took a lot of people's lives. More under control now, especially in the United States, not as much in other countries where their pollution isn't as heavily regulated. So for example, I have a friend who she went to teach over in Malaysia, and she had days where the smog was so bad from the factories and because it's hot and the sunlight is pretty intense there because it's close to the equator. There were days where they couldn't even leave their house because the smog was so bad, because it can be life-threatening. Now, here in the US, for the most part, we have it pretty under control. You will still see like a haze over some of the bigger cities sometimes. Like I remember when I was in Los Angeles visiting my brother many years ago, you could kind of like hike up into the hills and then you'd see over the city. You'd really just see like a layer of what looked like a cloud, but it was smog. So more common in big cities, especially when it's warmer outside too, because then the sunlight is more direct because that plays a part in it. And then also I didn't mention volatile organic compounds or VOCs and particulates. Those are literally just tiny little particles in the air. It can be dirt, it can be dust. And then here's a picture of smog in a city. I'm not sure where that one came from. Definitely a hazard for humans. Depending on how bad it is, it may not even be safe to be outside. But here's a video I want you to watch, and then pause this and come back. Okay, another type of pollutant is CFCs, or that is short for chlorofluorocarbons, CFCs. This is that long word, chlorofluorocarbons. In the 1950s and a little bit earlier, they were used as refrigerants, cleaning solvents, and spray can propellants. So like a spray, like cleaning spray or something. They did make their way into the upper atmosphere. There they reacted with the UV light coming from the sun. And with that, we have that ozone layer, remember, in the atmosphere. Anybody remember what layer of the atmosphere the ozone layer lies within? It's in the stratosphere. Second one up. So what happened is basically they kind of ate away and made holes in the ozone layer. Luckily, we did figure out this is what was happening, and then the Montreal Protocol was enacted to help just really decrease the use of CFCs. But unfortunately, there is a hole in the ozone layer over the South Pole, smaller one on the North Pole. You can kind of see they have a certain life. I believe it's 50 years. So after we get to like a certain amount of time, hopefully we'll see that hole get a little bit smaller. Definitely shouldn't be growing anymore now that we've reached this time frame. That Montreal Protocol was in the 80s, I believe. So we're almost at 50 years now. Definitely have to be careful with that UV light. It damages, cells of living things, whether it's human skin cells or plants, or aquatic invertebrates, things like that. The threat. Another one that we talked about when we did the gizmos was the greenhouse gas emission or greenhouse effect. And so any of those greenhouse gases are going to help or cause the earth to hold on to heat more. Remember how we thought about relating the greenhouse effect to the inside of a car. So if you have like all the doors shut, it gets pretty warm inside a car, even in the wintertime if it's sunny outside. that sun is a form of passive solar energy, and it just kind of heats up that air inside the car. Well, our greenhouse gases have that same effect. They kind of trap heat inside the atmosphere. So the three biggest ones are carbon dioxide. This one is the big one that's associated with any type of burning fuel. Transportation is the biggest. Also, electricity generation. Methane is another greenhouse gas, and water vapor. So natural processes release greenhouse gases like volcanic eruptions, respiration. That's normal. Like when I'm breathing, I'm exhaling carbon dioxide. Man-made sources, burning coal and power plants, the biggest one. Also transportation is not listed on there. So we don't want to have, in other words, more greenhouse gases than what would naturally occur, because as we have started to see, it is causing an average increase in global temperatures. And that is what you'll often hear referred to as global warming. So greenhouse gases. Watch this video, pause me and come back. So may increase global temperatures. Steady rise in global temperatures has been correlated with an increase in greenhouse gases. This is one of the famous graphs from, I believe it's from NOAA. It doesn't say it on there, National Oceanic and Atmospheric Administration. So this would be like the average temperature, and this is time on the x-axis. Average temperature is the straight line from 1960 to 1990. You can see that the temperature has increased. By 1990, it was by about 0.7, 0.8, and we're further than that now. Another kind of negative, I don't think I would classify it as a secondary pollutant, but a negative effect of air pollution is acid rain. And it can form in the clouds due to these gases entering the atmosphere: sulfur dioxide, nitrogen oxides, and ammonia. These gases can come from the emissions of vehicles and industrial plants. So once they're released in the atmosphere, they react with water vapor clouds and form droplets of actual sulfuric acid and nitric acid. That then falls to the surface as acid rain. So of course, there's going to be negative issues with acid rain. Destroys vegetation, eats away at man-made structures made of limestone and granite, washes toxic metals like aluminum. It leaches them from the soil and washes them into the actual waterway nearby, acidifying those waterways, threatening aquatic life. Again, we've had the Clean Air Act since about the 1970s. That's really helped cut down on all the pollutants coming from factories, from electricity generation, even from cars. A lot of states require emissions testing. So we've seen this on the decrease a lot too, which has been a good thing. And then some examples of water pollution: chemicals ending up in the water from manufacturing plants, dumping their waste into rivers and streams; from croplands, runoff with like fertilizers and pesticides; and even from agricultural areas, runoff of the waste of the animals. So of course, not good for the water. In the 1960s, I believe, was where the Cuyahoga River in Ohio caught fire because of all the chemicals that had been emitted there. It's from like some type of leather factory. Caught fire, so that was like the big eye-opening event. Then we had the Clean Water Act in the 1970s that helped kind of pave the way to cleaning up water, obviously not allowing companies to just dump directly into the water. And so, again, our water is actually a lot cleaner now than it was about 50-ish years ago. And then the last, or I don't know if it's the last, but one of the last big ones is garbage. So what do we do with our waste, our solid waste, like your trash? There's got to be a place to put it to keep us clean. You'll see in a lot of undeveloped or developing countries where they just kind of throw trash everywhere. And it not only looks, trashy and dirty, but it also is just not good for health. Lots of diseases are spread in the water. All right, so now we have landfills. There's been a couple big pieces of legislation that have helped us figure out and kind of place regulations on what to do with trash. Most landfills bury the trash. Some of them are incinerated, burned, contributing to air pollution, but I would say the majority buries. And then other hazardous chemical waste are difficult to dispose of. So there's different, usually like places where you should take those hazardous wastes. And it would usually say on the package of whatever that material was. And then here's an interesting little website that you can go to about how long do you think each of the following last when thrown in the trash. You can probably take some guesses, but I can't click on this to give you the link. You could probably Google this too to see how long some of these items might last in the trash. And so who cleans up the pollution? In the United States, the Environmental Protection Agency is the federal agency that kind of oversees these Clean Air Act, Clean Water Act, like these bigger pollution laws, and cleaning up the pollution. And again, always it comes back to money. So policymakers use economics to decide on acceptable pollution levels. Policymakers must weigh the cost of cleaning up pollution against the benefits of taking action. So it's always kind of this cost benefit analysis. It gets very complicated. It gets very political. You've probably heard people talk about it. But here is just an example of a cost benefit graph. So pollution eliminated, little versus a lot, and how much money, little versus a lot. So there's kind of like this cross in the graph where those two meet would be like the optimum spot. So maybe a little more pollution than environmentalists would like to see, and maybe a little more money spent on it than economists would like to see, but it's kind of a compromise. You can think of it that way. Cost benefit analysis. So it's not ever really going to be economically feasible to eliminate 100% of pollution, but if we can find a middle ground, that's going to be part of the key. And then you have a time to climb. So hope you've enjoyed this. Have a great rest of your day. It's been a good semester. Have a nice Thanksgiving, and we'll see you afterwards for a little bit of review and then your final interim. Bye, guys.